Hello to the audience, this is a demo video of our project, which is about evaluating the performance of UTP hole punching via a stun server. What UTP hole punching basically does is to allow the peer-to-peer communication between devices that is not directly exposed to the public internet, or in other words, devices that don't have static IPv4 address. The idea is to use UTP socket as a communication device, and the stun server let them know each other. In the context of evaluating the performance of UTP hole punching, we have think of 4 attributes. The first one is the connection establish time, which is the time for newly joined devices to communicate with other devices that are already in the network. The latency, which is basically the round-trip time for the direct communication between the devices. The throughput, which is the bandwidth of the connection between 2 devices. And the packet loss rate, which is the amount of packet that cannot be guaranteed that is transmitted successfully throughout a batch of sending. So before our example, let's introduce our example machines. So we have 3 machines here. The first machine is an ECS instance with public static IP. The second machine is a home device that located in China, and the third machine is our local machine that is using Windows OS, but it has a Windows subsystem or Linux. So let's just start by running the stun server. After running stun server, we can run a passive benchmark client that will not do tests actively, and then we can run active test client to perform tests. For example, we want to perform a latency test. Then we will start calculating the latency by the start of the program, and once it received some hello message from the other client, it will calculate the established time. And for the throughput test, we'll send as many packets as possible to the client in this duration and calculate how many valid packets are sent, so that we can calculate the throughput. And for our third test is the packet loss rate test, which will send packets in our defined frequency with the amount that we defined it. So that's it. Thank you.